Alright, this is going to be some practice problems dealing with free fall, so make sure you have an understanding what free fall is, and just be ready to do some physics. Awesome. Of course, before we get started talking about free fall, we're going to have to deal with the kinematics equations, or pull those up. So let's start off with the first kinematic equation that you were given. And here it is, dF equals di plus vt. Now this is dealing with constant velocity, and what that means for us in this situation is free fall velocity is not constant because of what free fall is. It's falling under the influence of gravity, so therefore it is accelerating. So in none of these problems are we going to have to worry about that equation, because, well, it's for constant velocity only, and these are not constant velocity problems. Now this equation, of course, we're going to use quite a bit. It's got final velocity, initial velocity, acceleration, and time. Now remember, in free fall, our acceleration is always the acceleration due to gravity, so in all these problems it's going to be negative 9.8 meters per second squared. And now, of course, we have one of the most useful equations, delta D equals VI times T plus 1/2 AT squared, and we'll use this problem on, or this equation on, probably most of these problems, so it is the most useful one. And then, of course, there's the equation that we use when we don't know the time, VF squared equals VI squared plus 2A times delta D. So these are the kinematic equations, and of course, as we work these three equations right here are going to be the key to solving these problems dealing with free fall. So let's go ahead and get started with the first problem. Okay, so number one, Gideon is holding a pen stationary in his hand 1 meter off the floor. While he is distracted, it slips out of his hand and free falls to the floor. How long does it take to reach the floor? And if he dropped a quarter at the same time, how long would it take to hit the floor? Okay, so we're going to take this in two parts, of course, because it's two separate questions. But first off, we're going to write down the stuff that we know. We know he's holding it 1 meter off the floor. So that means my initial position is 1 meter above the floor, and it falls to the ground. So since it falls to the ground, I know that my total displacement, delta D, is a negative 1 meter, because it falls down 1 meter. And I know that my acceleration is the acceleration due to gravity, because it's in free fall. So that's a negative 9.8, if my thing would work, meters per second squared. Okay, and I know that it's dropped. It's not thrown, it's not catapulted, it's not slung or whatever, it's just dropped. So that means my initial velocity, VI, has to be 0 meters per second, because he's holding it stationary, so it's just dropped, meaning VI is 0. Question wants to know how long it takes, so I want to know the amount of time it takes to reach the ground. Okay, well, we go back and think about all the equations that we just went over. I have one equation that has all of these variables. We have delta D, we have VI, we have time, and we know the acceleration. So I'm going to use this equation. Now the joy of this equation, in the fact that our initial velocity is 0, means that 0 times t disappears. So I'm left with simply having delta D equals 1/2 gt squared. So if I want to know the amount of time it takes, I'm going to have to solve for time. So the first thing I need to do is move my 1/2 by multiplying both sides by 2, and that gives me 2 times delta D equals gt squared, because when I multiply by 2, the 1/2 and the 2 right there will cancel out. Now I need to move the g. So to move g, I have to divide by g on both sides. Okay, and that gives me 2 delta D divided by G equals t squared. So then, in order to get t by itself, I'm simply going to take the square root of both sides, and when I square root t squared, the squared goes away, and there's my equation. T equals 2 times delta d times the square root of g. So now if I take the numbers from my problem and I plug that in, t is going to be the square root of 2 times negative 1 divided by a negative 9.8 meters per second squared. And then I'm going to take my calculator, plug all that in, and get a final answer of time equaling 0.45 seconds. So that is the answer to how much time it takes for it to fall. Now, part B, if you dropped a quarter at the same time, remember you dropped a pin to start off with, so you dropped a quarter at the same time, how long would it take to hit the floor? Now again, this is a free fall situation, which means the only thing acting on these objects is gravity. If they're exactly the same height and they're both just dropped, then nothing in this equation anywhere on this problem is going to change. So the answer to B is exactly the same as the answer to A, and the reason is because gravity treats all things the same. That's what we talked about in our notes the other day. And so remember that gravity treats all things the same way. It doesn't matter how big or how small. If we're in free fall, meaning we're ignoring all other forces except for gravity, then they will fall at exactly the same speed. And so they'll hit the ground at exactly the same amount of time. So let's move on to the next question, number 2. So number 2, free fall is a useful method for estimating vertical distances. Asher wonders how deep a well is, so he drops a rock in and waits to hear it hit the bottom. If the rock takes 2.85 seconds to reach the bottom, how deep is the well? Okay, so we know that the rock has a time of 2.85 seconds. And we know that the acceleration is negative 9.8 meters per second squared. And we know that if he's dropped, the initial velocity is 0 meters per second. And what we want to know is how deep the well is. So delta D is what we're looking for. So again, we're going to use the delta D equals 1/2 GT squared plus VIT. But since VIT is 0, I'm just going to not even bother writing it this time. So if I want to know how deep the well is, I don't even have to do any algebra because it's already solved for that. So delta D equals 1/2 times negative 9.8 times 2.85 squared. So let's get our calculator and plug that in. And that gives us an answer of negative 39.8 meters. And of course it should be negative because the rock is falling down and it's going below the well. So the next part of the question, part B, is how fast will the rock be going the instant it hits the bottom of the well? So now we're looking for its final velocity. And since we know the displacement, we can find the total velocity, but I'm not going to use that equation. I could use the one with the v's that are squared, but that's really complicated whenever I know that my final velocity is what I'm looking for, and my initial velocity plus a t. Well, my initial velocity is 0, and I know that a is negative 9.8, and t is 2.85, so I can simply plug in my VF is going to equal negative 9.8, my acceleration, times my time of 2.85, and then I plug into my calculator, and I get an answer of, let me move that up a little bit, negative 27.9, that's 9, meters per second. So that's my final velocity. And of course it's going down, so it should be negative as well. So that's the answer to number 2. Let's go on to number 3. Okay, number 3. Liam climbs to the top of a 5-meter platform at the pool and steps off. How fast will he be going when he hits the water? So we know that his delta D is 5 meters, and it's actually negative 5 meters because he's falling down. And his VI is going to be 0 meters per second because he just steps off, he doesn't jump off. And we know that his acceleration is little g, which is negative 9.8 meters per second squared. And there's an equal sign there. Alright, and we want to know the final velocity. Okay, so this time we are going to use the equation Vf squared equals Vi squared plus 2 times, I'm going to put G for A, times my delta D. So once again, my initial velocity is 0, so I take that out, and so now I just have Vf squared equals 2G delta D. So if I take the square root of this side, then my squared goes away right there, and so Vf is simply the square root of 2G delta D. And so let's plug in our numbers. Vf is the square root of 2 times negative 9.8 times a negative 5. And so you see that why it's important that we recognize that it's a negative 5. Otherwise we'd be trying to take the square root of a negative, which we can't do. So let's plug this into our calculator. And we get an answer of Vf equals 9.9 meters per second. It's 9.899, so I rounded to 9.9 meters per second. So I'm actually going to write this, since it's falling downward, we're going to say that that's a negative, but since the question does just ask for how fast he's going, we could think of that as speed, so we don't need the negative. Direction doesn't matter, we know he's going down, but I'm going to put the negative anyway just because I feel like it. Alright, and part B, how long will it take Liam to plummet to the water below? Well, now for that one, I am going to use the equation that says Vf equals Vi plus AT. And since we've done this before already, I'm just going to go ahead and do the algebra here and say that time is going to equal Vf divided by my acceleration. And since my Vi is 0, I left it out of the equation. So let's plug in those numbers. Vf is 9.9 meters per second, and you'll see that it's important that it's negative now because I'm dividing by a negative 9.8, and so time can't be negative, so I have to have a positive value for time, and so that gives me an answer of time equaling 1.01 seconds. So to fall 5 meters it takes roughly 1 second. That's fun. Alright, so that's the third question. Let's move on to question number 4. Okay, number 4. Keziah tests her vertical leap and finds that she can jump 0.3 meters off the ground. Part A, how fast is she traveling the instant she leaves the ground? This time we want to know the initial velocity. How fast is she going? Oops, that's not a 0. How fast is she going when she leaves the ground? That's our question. So we know that the acceleration is negative 9.8 meters per second squared. We know that her displacement is a 0.3 meters above the ground. I don't know why I started to write meters per second there, but it's meters. And we know that her velocity at the very top, before she comes back down, when she's at that 0.3 meters, her velocity has to be 0 because you have to stop before you can come back down. So if I want to know how fast she's traveling, I want to know VI. So I'm going to have to use this equation again. The VF squared plus VI squared, or equals VI squared plus 2G delta D. So now we're going to solve this equation for VI, so I'm going to subtract by everything else, and I'm just in my own head here for a second, and I'm going to subtract by 2A delta D, and my A is little g, and that's going to equal VI squared. So then I'm going to take the square root of all of that so that I can get rid of the squared over here. So once again, something here is 0. This time it's my final velocity is 0. So my final equation that I'm going to have here is VI is going to equal the square root of a negative 2G delta D. Now, you might be thinking, well, I can't take the square root of a negative. Remember, little g is negative, so those negatives go away. So I plug in my numbers of negative 2 times a negative 9.8, which gives me a positive number, times my delta D of 0.3, and then I take the square root of all of that to get my VI. Let's put that in our calculator. And we get an answer of VI equaling 2.42 meters per second. Okay, so that is our answer for our initial velocity. Now for the fun part, how much hang time will she have? I'm going to go ahead and slide this up a little bit, because hang time is, well, we need to know time. Well, we know that her final velocity is 0, and we just found her initial velocity, and we know why. I need to start thinking more while I'm talking. We know that we have her g, and we're solving for t. So when I do the algebra, that gives me VF minus VI equals GT. So I divide by g, and that will tell me my t. So then I can simply plug in my numbers. VF is 0 minus 2.42, my VI I just solved for, divided by a negative 9.8. So the negatives cancel each other out, and let's put that in our calculator. And we get a time of 0.25 seconds. Now that's the time it took her to go from this speed of 2.42 to this speed of 0. That's just the way up. So, in fact, her total time in the air is twice that. And that's the key to hang time questions, is the time it takes to go up is equal to the time it takes to go down. So the total time she's in the air is 0.49 seconds whenever you do the stuff and around it. So remember, hang time is time up and time back down. So the time it takes to go up and the time it takes to come down should be the same because you're going the same distance with the same acceleration. So those times should be the same. So that's number 4. And let's move on to number 5. Alright, so number 5. Jael stands around tossing a tennis ball up and down while waiting for her parents to pick her up from school. Her hand is about 1 meter off the ground when she lets go of the ball. If the ball leaves her hand at 5 meters per second, how high above the ground will the ball be at its maximum height? So, what do we know? We know that the initial displacement is 1 meter. We know the initial velocity is 5 meters per second. we know that the acceleration is little g, so that's negative 9.8 meters per second squared. And we know that the velocity at the top is 0 meters per second because it has to stop before it can come back down. So if I want to know the final position or how high it goes, I need to know how high it goes. So let's look at, we don't know time, so we're going to use the equation VF squared equals VI squared plus 2 times G times delta D. And remember that delta D is your final displacement minus your initial displacement. So I'm going to go ahead and replace delta D with that in the equation. And so I have dF minus di. And now we're going to do our algebra. So the first thing I'm going to do is subtract VI squared from both sides. And that gives me VF squared minus VI squared equals 2 times G times dF minus di. And then I'm going to divide both sides by 2G. And let's go ahead and move this up so we have a little more room. We now have the equation VF squared minus VI squared divided by 2G equals, now I don't need the parentheses because, well, everything else is gone. So now if I need to know DI, I need to know DF, I add DI to both sides. And so I get a final equation of VF squared minus VI squared divided by 2G plus DI equals DF. So if I now plug in my numbers, we know VF was 0, VI was 5, and 2 times a negative 9.8. Now be careful when you plug this into your calculator. Remember, you're subtracting and 5 squared. So when you put it in your calculator, put that in parentheses so that you have a negative. Otherwise you'll end up with a negative number, and it's going up, so it needs to be a positive number. And your DI is 1. So let's write a 1 there. So that's your equation. So we are going to put this in our calculator, and we get an answer of 2.276 meters. So there is how high above the ground the ball goes. Now we'll go ahead and clear all this and go back to the original question so we can answer part B. Now part B seems a little bit complicated, but it's really not. If she misses the catch on the way down, how long will the ball be in the air from when it leaves her hand to when it leaves the ground? So let's think about the situation. First off, the ball starts out 1 meter above the ground. It's going to go up and come back down. So we want to know the time it takes to go up and back down, or simply the time it takes to go from here to here, which means my delta D is negative 1, because it starts 1 meter above the ground and ends at 0, so it's going down. And we know that my acceleration is a negative 9.8 meters per second squared. And we know that the initial velocity is 5 meters per second up. Now in order to find time, we could either use the big long quadratic equation and use the quadratic formula to solve for time, but that's kind of complicated. So instead we're going to solve for VF and figure out what that is. And we know that VF F squared equals VI squared plus 2G delta D. So, of course, VF is the square root of all of that. Let me just get rid of that. Okay, so let's plug in our numbers. So, VF equals the square root of 5 squared plus 2 times a negative 9.8 times a negative 1. And then we plug that all into our calculator. And we get an answer of VF equals 6.67 meters per second. Now this is going to give you a positive number, but remember when you take the square root of something, your answer is either positive or negative. So we have to think about the situation and realize that the ball is going down, so this final velocity should be a negative number because it is going down. So let's go ahead and write it as negative. Now the question wants to know how long it takes. So now that we know our final velocity, we can go to this equation, VF equals VI plus AT, and solve for t. So we subtract VI and we get VF minus VI equals AT, and then we divide both sides by A, and that gives us our t. So now if we plug in our numbers, our final velocity that we just found was negative 6.67, and I'm going to subtract a positive 5. That's going to give you a negative 11.67. And then I'm going to divide by a negative 9.8, and that gives you a time of 1.19 seconds. So that's number 5, A and B. That is the last question, and hopefully that helps you.